So for problem number 16, 16 through 19, we're graphing exponential and log functions. So we know that exponential always have a horizontal asymptote, and the horizontal asymptote is always going to be y equals that number right there, y equals 2. So we can just go ahead and draw that. Horizontal asymptote, y equals 2. So maybe you might be asking yourself, well, why is that? Well, when you start off, you want to be thinking that about what the parent function is. So the parent function for this function here is y equals e to the x. And we know that y equals e to the x looks like this. Comes up, goes like that. Always goes through. All the exponential graphs go through 0, 1 because e to the 0 is 1. And then if we replace, first of all, the minus sign in front means we're going to reflect this graph about the x-axis. So we want to reflect first, reflect, and you want to reflect in the x direction first, then in the y direction. Then we want to shift in the x direction, then the y direction. So that's the order in which you'll apply your transformations of the parent function. So because the minus sign is out there, that means we reflect this parent function about the x-axis, which means it's going to go down like that. Now we have the key point at 0, negative 1. And then the x minus 2, replacing x with x minus 2 means we're going to go 2 to the right, 1, 2. And then having this plus 2 on the outside, like this, maybe it's easier for you to see it if it's y equals negative e to the x minus 2 plus 2. If you see it that way better, then rewrite it. You can put the 2 over there, that's fine. But that 2 means we're going to go up 2, 1, 2. All right, and since we went up 2, that's where that horizontal asymptote came in. So we have a horizontal asymptote of y is equal to 2. And then the graph will look just like this guy that moved to the right 2 and up 2. Okay, so we just draw the graph. Don't worry about much else other than drawing the graph exactly the same way that should look. And we can find the domain, always all real numbers, the range from the lowest y all the way to the highest y, not including 2. The x-intercept, so that gives us something else to do now that we have learned how to solve these kinds of equations. The x-intercept, let's see, so we're going to let y equals 0, and we're just going to rewrite the equation. 2 minus e to the x minus 2. Adding e to the x minus 2 to both sides gives us positive, positive. That's what we like. Now we have, remember the Punnett square, we have the bases cannot be written as a power of the same number, or the bases can't be the same. E and 2 are two different bases. That means we're going to convert to logs. So we can rewrite this. Log base e of 2 equals, meaning log base e of 2 is equal to x minus 2. Adding 2 to both sides, we get 2 plus ln of 2 is equal to x. That's the x-intercept. 2 plus ln 2, comma 0 is the x-intercept. You can't simplify that anymore. ln of 2 is a number, you're adding it to 2. So ln of 2 is an irrational number, means the decimal goes on forever, and adding that to 2. So we have, I mean, we don't know what it is, but you've already drawn the graph, so it doesn't really matter. You just draw it, and actually I shouldn't say it doesn't matter. You should kind of check and make sure you drew the graph in the right place, because if you show a graph, let's say above the horizontal asymptote, and it doesn't show an x-intercept at all, then there's a problem somewhere. Like here you show that there's an x-intercept, and on your graph that seems reasonable. 2 plus ln of 2 seems reasonable. Okay, so you got it. Looks like you've drawn your graph correctly, and I don't see any mistakes in the x-intercept either. So let's go ahead and find our y-intercept. Y-intercept is when we let our x equal 0. So we have y equals 2 minus e to the 0 minus 2, and you can leave it just like that. You can write 0, comma, 2 minus e to the negative 2. That's an okay way to write that. If you want to write 2 minus 1 over e squared, that would also be okay. So you can leave it just like that. I think I'll probably make a new video for each graph.